So we're going to first discuss today binomial probability. I'm going to show you how the formula works, and then I'm going to show you how we're really going to do it, which is on the calculator. And then we're going to come back and revisit this concept again towards the end and possibly a little tomorrow at the beginning of the lesson. So a binomial probability question would be in an experiment where there's only two outcomes possible. So like it either will rain or it won't. You're going to win or you're going to lose, you know, things like that. It says something about later doing binomial expansion with Pascal's triangle. That's kind of, I think that's a lie. I don't think we're going to get to that. Sorry. But maybe. We're not really sure. We haven't mapped out the rest of the semester yet. So to be continued, let's say that. So here's the formula. And it is on your formula sheet. But I'm going to show you how to use the formula first. And then I'm going to show you how we're really going to do it. And it's not using the formula. So the first part of the formula is a combination. Remember yesterday we had a combination? So it starts out with a combination. N is the number of trials. You might want to write this down somewhere in your notes. N is the number of trials. P is the probability of success. Q is the probability of failure. And they don't mention it here, but X is just the variable statistic. So it's like, it'll say things like you win 3 out of 5 times. 3 would be the X in that case. So I'm going to say the number of successes, although sometimes we phrase it weird and they're not actually successes. So N is always the total number and X is how many of those total number you're interested in. So keeping that formula in mind, and it is on your formula sheet, let's take a look at an example, and it's about golf, so you know it's going to be good. So a golfer can drive a ball to the fairway about 70% of the time. So this right here is what we would consider the probability of him being successful. That's P. So we're going to write P as 0.7. It can be written as a decimal or a fraction. Now because P is 0.7, what else do we know? What's his probability of failure? 30%, 0.3. So the last part of the question is the N and the X. So what is the probability that he will hit it onto the fairway exactly 14 out of 18 holes? So 18 is the N, that's the number of trials, 18 holes of golf, and 14 is the X, his number of successes. So what we're going to have to set up first is just handwrite the formula on our paper, and then we're going to transfer it to a calculator. So it goes 18 combinations 14. You can put a multiplication sign there if you want. I usually do just because I like to write it. And then it's the probability of success, which is 0.7. And we want that 14 times. And we're going to multiply that by the probability of failure, which is 0.3. And that would be, notice in the formula, it's n minus x power. Well, that's just how many times he fails. So for us, n minus x would be 4 times. 14 wins and 14 fails. And that's what you get to type in your calculator. So I'm not going to because I trust you guys can type. When you get out of the combination, remember to pop out of it before you start multiplying the rest of it, please. And you should get 0.168. But I need a little confirmation from y'all that we do get 0.168. Cool. All right, so he's got not very good chance of doing this, unfortunately. Yes, sir. Combination, you got to go to math, over to probability. And then the second or third one down maybe is NCR. You got it. All right, can I show you how to do this on the calculator, though, the quick way? Please, Abruzzo, please. Oops, that's not it. Was everyone able to get 0.168? Getting there, getting there. Okay. So this is called a binomial distribution. Remember how we had the normal distribution on previous questions? Well, when it's binomial probability, it's a binomial distribution. So go back to that distribution menu. And it's kind of down the list, almost towards the middle bottom, so I'm actually going to scroll up. And you have two options for binomial distribution, binomial PDF and binomial CDF. Now for normal distribution, I had you guys choose the CDF because we're calculating a bunch of them and adding them together, like between a range. For binomial, that's actually really quite hard to do a range because you have to remember how the graph is read. So we're not going to use binomial CDF in this class at all. But like James, if you remember how to do CDF binomial, because remember how you have to round down to the previous one for binomials, but yet it reads the left bound of the curve. So if you need the upper bound, you got to take the complement to it. So you're welcome to do that. The rest of us, we're just going to add up a couple of numbers. It'll be fine. So we are always going to use binomial PDF for these, okay? So choose binomial PDF. And if you have an older calculator, you're going to type in what I'm about to type in the exact order with commas in between. Second varies. And the distribution menu, go down to like A, I think it is, binomial PDF. Okay, so there was 18 trials. His probability of success was 0.7. And he was going to succeed hopefully 14 times exactly. Oops, Abruzzo, what are you doing? 14. It's going to paste it into the formula, which is, this is what the older calculators would look like. Same order, commas in between them. Hit enter, and look at that, 0.168. So that's better. So we're going to use that. I'll be honest, I don't think I'm ever going to use that long formula again. If that's okay with everybody. I mean, if you really want me to, I can. So on the next question, just read carefully. Those of us who are getting ready for our SAT are all about reading carefully today. The probability that a substitute teacher has to work on Friday is 32%. So this is considered a success in his mind, that he wants to know what's the probability of him being called to work on Friday. So his probability of success is 0.32. With that in mind, can you tell me what the probability of failure is, just for funsies? 0.68. We don't actually need that for the calculator distribution, but it's fun to know. What's the probability that he will be called to work on 3 of the 4 Fridays in the upcoming month? So 3 is your X, and 4 is the total number of trials, or the largest outcome. So on my calculator, I'm going to pull up that binomial PDF again. And they abbreviate it, of course, binom PDF. And you start with, is it trials first? I always forget trials first, right? And so 4, comma, 0.32, comma, 3. And this should be a pretty low number. So like 0.089 or 9%. And if you think about that, like just from a human standpoint, he only has like 1/3 of a chance of being called to work, like on any given day. So the chance that he's called the majority of the days is going to be pretty small. Yeah. All right, this one's a little more complicated. So this is, James, this is going to be a cumulative one if you want to try it, okay? On average, a player misses 3 free throws out of every 8 attempts. Well, that's a really negative Nancy way to say it. If they miss 3 out of 8, what does that mean for like succeeding? They make 5 out of 8, right? So our probability of success on this question is just 5 out of 8, and I'm going to leave it as 5 out of 8. So if the player attempts 5 free throws, so this is the n, the number of trials, what's the probability that he misses no more than 2 times? So what they're asking me is, what's the probability that he, okay, if he misses no more than 2 times, what are we talking about then? So he would make, he's totally shooting 5 this time. So he could make 3, right? Would that work? What else? Or 4? Or he'd make all 5. Okay. So this is not necessarily a binomial PDF the way it's written right now. If you had knowledge of how the stats curve works, you can use binomial CDF, but what we're going to do is we're going to find these 3 probabilities and just add them together. So I'm going to have you do binomial PDF still, and you're still going to say there's 5 free throws shot, that's your trials. His probability of success is 5/8. But this number x is going to change, and we're going to do it 3 different times. So the first time is you're going to plug in a 3, and then you're going to plug in a 4, and then you're going to plug in a 5, and we're going to write those answers kind of down the paper. But here's what I would like you to consider on your calculator. You don't have to pull up the binomial PDF every time, right? You can just pull up the previous entry using your like history. Like, I wouldn't do this one necessarily because I'd have to overtype it, but rather than retyping the whole thing every time, if you're just changing the last number, just do that. So I already forgot what it was. Was it 5? Comma, 5/8. Comma, and it doesn't matter which one you find first, second, third. I'm just going to find 3 first, but I got to delete that. All right, there we go. So I'm going to jot this down on my paper, I hope. So that I'm going to make a little note. These are my notes, right? So he makes 3. That was a probability of, oh, I didn't write it down. Now I forgot what it was. 0.343, sounds good. All right, so then we're going to either bring it back up again or type it all again. What if he makes 4? So I'm going to go up in the history. I'm just going to kind of steal this. And I'm going to go back to 3, and I'm going to change it to a 4. So it's not the end of the world, guys. It's not a ton of typing. So jot that number down, 0.286. And then probability that he makes all 5. I don't know, but I bet it's pretty low. You guys found this like a year ago, huh? Just slow me. Sorry. Okay. 0.095. And then what we're going to have to do, of course, is in our home screen, we're just going to add these all up. And you're going to get your total probability of approximately 0.72. Can someone give me to the thousands place, though? Thank you. So 72.4% chance that that's going to happen. Did you try the CDF on your calculator, James? Do you want me to show you how? Okay. Everybody else, if you don't want to learn about this, just etch a sketch it for a moment. What James would have to do, because he has a little knowledge of this, is he'd pull up Binomial CDF, which is going to accumulate, but remember the curve reads from the left, from the point down to the left. So he still has, I forgot what it was, 5 trials. Probability of success is also 5/8. But the way the curve reads is because it's like integer values, right, James? So if we were looking at like 3 or higher, you would have to put your x value at the one right below it. So you'd have to put it at 2. It's always like x minus 1. And then when you do this on your calculator, it's going to have all the accumulated probabilities all the way from that point down to the left of the curve. But then remember, we wanted the positive, the upper side of the curve, so you have to find the complement. So 1 minus this. So, same answer. Obviously less work. If you remember it, cool. If you don't, it's fine too. Those of you who just stared at me and went, that was interesting, wait for stats class, okay? You learn it all about it in stats class. It's a good time. All right. There's some assigned problems for you tonight on that page. Number 27 and 28 is what you're going to do for me for homework. Just be careful that you are using the appropriate numbers in the right spot on your calculator. I assume all of you are going to use your binomial PDF on that one, on those two. All right, so the next part, is it the next page? Yes, is it worksheet 8? Fantastic. So there's a lot of stuff coming up on these next few slides that you already know, so we're just going to kind of buzz through the slides because I don't need to look at them. Mean, median, mode, and standard deviation. Do you know how to find them on your calculator? You put all your data into list 1, and then you do one variable stat. Well, what I want to look at today is what happens when you have a frequency list as well. Because those of us who've been working on SAT, we have seen that a little bit on the SAT too. All right, difference between population mean and sample mean are in the notation. As you move through a stats class, those two become very important because if you're looking at a sample versus a population, you have to be careful which standard deviation you use. At no point do you guys need to calculate these by hand for PreCalc. You're going to be using your stat menu the entire time, and I'm going to very explicitly ask you for which one. I'll even use the right notation on the test. Like if I want population standard deviation, I'll put this little sigma symbol down so you know what I'm asking for. So I'm not really worried about all this, and I'm really just going to buzz through it. Basically, the idea for standard deviation is it tells you how spread out the data is, and it's based off of a calculation called variance. So variance measures the distance from the mean to the actual data points on the scatter plot, essentially. So if they're very close together and they form a really tight function, there's not a big spread of data. But sometimes there is a lot of variance, and then you get a bigger standard deviation. Do you notice the difference between population and sample in the formula? So the top is different in both of these because they're taking the statistic minus the mean versus the statistic minus the sample mean. So if you're looking at a sample, you'd use sample data. If you're looking at a population, you use population data. But notice in the denominator here, they're dividing by n for the population, and they're dividing by n minus 1 for the sample. What happens when you divide by a smaller number? So like for instance, if you took 1 and divided it by 4 versus 1 divided by 3. What's bigger, 1 divided by 4 or 1 divided by 3? 1 divided by 3 is bigger. You fooled me for a minute. So the smaller the denominator, the larger the number that you're going to get. So what happens in stats is when you have a sample, the data is not very good in a statistics point of view. So they're going to have a larger variance and a larger standard deviation because of it. Okay? A little more spread out data. All right. Blah, 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 blah. We did this already. Remember your box and whisker plots? They were a hoot. You loved them. Right? So what you're going to have to do for your test on next Friday is I'm going to give you some list 1 data. You got to crank it in. You got to get me the 5-number summary, which remember was min, Q1, median, Q3, max. And then you have to tell me whether there's an outlier on that box and whisker plot. So you have 2 ways to figure that out. We will totally review that before we test, but you can either just graph a modified box and whisker plot. That's the easiest way. Or you can do the 1.5 interquartile range thing where you take away from the median and add to the median. That's a little more elaborate. If you want to do it that way, you can. For most of you, if you're lazy like me on an SAT week, you're just going to go, yeah, you know what? I'm going to graph the modified box and whisker plot. And when my teacher says, how did you figure this out? I'm going to go, I graphed the modified box and whisker plot on my calculator. I think that's fine. All right. This is on your notes, right? Discrete versus random. So a discrete versus continuous. A discrete random variable, you can count them. They're countable numbers. A continuous variable, you have decimals in between those numbers, okay? So if I was asking you to measure like the heights of my children over the next 4 years, that is a continuous variable because like they can range anywhere between this distance along the wall when I'm making those pencil marks, right? But if I was going to ask you to count the number of school buses that pass by the front of our school, that is a discrete random variable because you can count. You can't have 2.5 buses, can you? You have a bus, another bus, a bus. So that's the difference in the variables. It does change the way your data looks when you go to display the data, because if you're just counting something, you get this jagged like histogram looking thing or a frequency graph. If it's continuous, you would see maybe a smooth curve like a normal distribution. We'll talk about this later. All right, you guys do some questions for me. X represents the time it takes to serve fast food at a restaurant. Is that discrete or continuous? I think I heard someone whisper continuous. You going with continuous? Okay. And then 1B, X represents the attendance at a randomly selected monthly school board meeting. So if you're counting how many people attend a meeting, is that discrete or continuous? That is discrete. Very good. You would count a person as a person, and they would be counting by integers, right? 2 people, 5 people. Okay. Oh, the examples they already have done for you. These are out of your book. The weight of a cereal. Weight of cereal in a 15-ounce box. So they're saying it is continuous because, like, it could measure 15.25 ounces. It could measure 15.34. All sorts of different decimals in between the values. And then anytime they say number of, usually that's an obvious get-go that it is going to be a discrete variable because number of indicates that you're going to count them. So number of cars. All right. Oh, you already had problems. Let's do these. X represents the time it takes a classroom to reach 68 degrees from 60 degrees. So I turn up the thermostat. How much time is it going to take? What do you think, guys? Is that discrete or continuous? It is continuous. Very good. And then the number of photographs taken by a photographer. That is clearly discrete. countable. All right, there is a question on a homework assignment that I think you were given like right off the get-go, and maybe it confused you. It asked about a probability distribution, and I think there's one, a frequency distribution, like on that first book assignment. Yeah, and you were waiting to ask me about it, weren't you? Well, good news, it's all going to be clear today. So a probability distribution looks a lot like a histogram, or sometimes they graph them as line graphs and line plots. But instead of graphing like the frequency and the number of them, they change it to probabilities. Let's look at some examples here. Let's just do the one that's in your, okay, right here. This is from your book. It's not on your paper. So they have this table for all of these scores, and they have it as a frequency table. So just like that weird question that we had on SAT prep, my juniors who were watching earlier, and we had it on our yellow packet, where like, this is how many people scored a 5, this is how many people scored a 4. This is just how many people scored these scores, or how many times the score showed up. So 1 showed up once, the score of 2 showed up 8 times, and 3 showed up 20 times, and so on and so on. So what they would do in your book is they would instruct you to find the probability, and usually we write it as a decimal because it's easier to graph that way, of each of those probabilities, and they'd kind of make like a third column over here. They change it all to probability. And then what they would plot in a histogram looking graph is a probability distribution. So the score of 1, while it showed up 1 time, when you converted it to a probability decimal, now it's graphed as a 0.2. So you'll notice along this y-axis, they have a decimal range of probability. Now what's the highest probability you could possibly have? Can't go past a 1, right? And in theory, even smaller than that for these questions, because none of them exceeded like 50% at all. So when you're going to label your axes on that question in your homework, just be smart about it. Like if you notice the probabilities range from, you know, very small up to 0.6, then maybe just make your vertical axes go like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So that's what you're going to be looking at for that question. And they plotted all the probabilities. But what do you notice that this has in common from like the other distributions that we saw? Can we still identify skewedness here? So this one looks pretty uniform, not uniform, excuse me. This one looks pretty normally distributed to me. It doesn't appear to have tons of skewedness to the right or to the left. So your calculator can also graph probability distributions for you. We'll talk about that. All right. Big note. Write this down in your notes, guys. If you have a frequency list, which we're going to have on this problem, you're going to have to put your frequency list into list 2 today. Okay? And we're going to be using your calculator, which means I'm not going to have to find anything, and it's going to be beautiful. All right. I don't want to do extra work today, guys, because I don't have tons of time. So, is this the problem you have? Oh, I skipped one. Is there one about books? Do you have one about books on your paper? Oh, it's already done. Well, that's horribly boring. Let's skip it. All right, let's go to number 3. This guy. Okay, so this one, we have a table that shows medical tests done on 15 random patients, and then we marked up the results, but also the frequency with which they occurred. So what I would like you to do first is let's just find some quick probabilities. And can I show you something kind of neat? You're not going to want to do this necessarily like all the time on these shorter problems, but go to Stat Edit. Of course, I have crap from before. I did not prepare. I'm so sorry. Usually I have mine entered. Could you enter the recorded results into list 1 and the frequency into list 2, and then just stop and wait for me? Oh, why did I delete that? I think I already had it. Dang it. All right, it's been a while since I've had to do this, but once you have list 1 and list 2 entered, notice, guys, the frequency is in list 2, right? You got the frequency in list 2. Can you go up to the name of list 3? And I think, I haven't done this in a while, but I'm pretty sure I can do this. Let's see. I am recording, so that probably means I'm doing this all wrong, and I'll have to edit this out. Let's try. I want this list to be the probabilities of this. So what I'm going to do is I'm going to command it Let's see if it works. I'm going to command it to take list 2 and divide it by the total number of patients for each one of them. So isn't the total number 15? Let's see if this works. It's about to be a big failure, I bet. List 2 divided by 15. And then hit enter. Look at that. Go me, go me. Do that again. I wasn't watching because you all thought I was going to fail. So you didn't want to do it. I see what happened. Go up to the name, like this is the calculation bar for list 3. And then I want you to type list 2, which is second, and then over here, number 2, divided by 15. So what it does is it takes every entry from list 2 and it divides them all by 15. And it gives you 2 decimals. So what did I just find? All those little probabilities. Isn't that nice? Okay, so obviously you only had like 4 things to divide, so you're like, that was stupid. Like, I could have done that by now. But what if you had a list of a whole lot of things? That would be nice, right? I think you all have used some version of Excel or some sort of a cellular table in Microsoft or whatever you guys are using these days. You can command the formulas, and that makes your math go really fast rather than you hand calculating each of them. All right, cool beans. Back to my table here. I didn't fill out anything yet, so I should probably do that. Can you guys read them off to me? Because I didn't write anything down. 0.4, 0.33, 0.2, 0.7? Okay, that's fine. All right, so obviously your calculator kept more decimals than I'm writing down, but you got it, you got it. Now it does want you to find the mean and the variance and the standard deviation. So what you would have to do is exactly what it says here. Pull up one variable stats, and your data scores are in list 1, but remember this time you put a frequency list into list 2. So rather than writing like 0, 0, 0, 0, 0, 0 6 times, it's going to magically multiply your frequency list together. It's going to be beautiful. So put list 1 for the list and put frequency into list 2, and then go ahead and calculate it for me, guys, and tell me if you get this same data. I hope. Okay, cool. Now, technically speaking, guys, we are looking at a sample. So the sample mean is 0.93. The sample standard deviation is the S. The population standard deviation is this weird sigma thing. So you might be curious, like, well, which one do you want? On the test, I will very explicitly ask you for one versus the other, so that's how you will know. It'll say like the symbol and everything. Okay. And then as far as interpreting for us is really just writing down those clues in with words. So the sample mean, what was this on again? The sample mean. So according to this sample, the average number of tests, medical tests that a patient had at this hospital was about 0.93 tests, which for a normal human, we'd call that 1, with a standard deviation of about 1 as well. So you're going to have 1 test today, give or take 1 test, is what that's saying. That's great. Great. Except for that lucky ducky who had 3 tests. Fun. Must be his birthday or something. All right. Keep going here, guys. We have binomial distributions. We talked about the probability of success and failure already. So that binomial probability that we were discussing earlier, it's the same thing now. There's that glorious formula. We love it. Already did it. We're going to use binomial PDF on our calculator because that formula kind of stinks. These are all from your textbook. These are some examples of why something can be considered binomial versus why it can't. So I just want to read through one example with you because it's not going to be a problem for pre-calc students on my test because I'm not going to ask you this, but as you move on in your stats life, it will be very important. So this example says the results of a school survey indicated 68% of students own an MP3 player. 6 students randomly selected asked if they own an MP3 player. Okay. The random variable represents the number of students who say that they do own an MP3 player. So the first question you would ask yourself is, if this is a binomial experiment, is if there's only 2 outcomes to their questioning. So when I go up to you and I say, do you own an MP3 player? What are your options for answers? Yes and no. So right there, yes, we're on track to be a binomial experiment. Only 2 outcomes. The other thing that they want to point out to you is that every person that you ask is considered a trial. So, like, there's an example coming up in your book. I don't think we'll get to it, but it doesn't make sense to call it one trial. And then the probability of success is the same for each student selected, so 0.68. Okay. So, I don't know how they figured that out, but cool. All right, so you can then find the probability of success and failure. They didn't interview a lot of kids, I noticed. I feel like the stats person in me is bothered by this experiment, but whatever. This question, however, you have 5 cards drawn at random from a deck, and the random variable represents the number of spades. Now, they're claiming right away that this is not a binomial experiment, because as you draw a card, now the fact of me answering, is it a spade or not, that is a binomial question, right? The answer is yes or no. It's either a spade or it's not. But every time you draw a card from the deck, what happens? The probability changes, right? Like anyone who's watched like poker on the TV, like every time something is put on the table or somebody throws down a card or picks up another card, those probability percentages, they all change. Now obviously a computer's calculating it, not a human at that point, but like every time you move a card out of the deck, probabilities change. So therefore you can't consider this to be a binomial experiment because every change that you make is going to affect the probability of success. So it doesn't stay consistent like we wanted to see in the binomial. Alrighty? And then there's a big line that says stop, so I'm going to stop. Can you guys get out that yellow packet? I feel like we have more to do in that yellow packet. So as far as homework goes for tonight, guys, you are now on track to do those 2 problems on worksheet 7B. And then there's some questions on worksheet 8.5B, like our numbering. So it's on the homework check. It's under the binomial stuff today. You'll see it. I hope you guys are trying to catch up a little bit on the homework. I know I kind of set you up for failure at the beginning of the week, but we're back on track, I hope. Maybe a bruiso. I don't know. All right, where is my packet? Where are we at, guys? You are actually the furthest class, first hour. Because you love the SAT so much? I'm guessing. You know what it is? We have more seniors in here than any other class. All of my seniors are keeping the pace up, right? You guys love the SAT. Guys, where did we leave off? On SAT number 6? Yeah. Cool. Right there. We didn't do this one yet? Okay, cool. All right. Oh, look, another table. All right, so the table shows a summary of 1,200 responses to a survey question. Based on the table, how many of those surveyed get most of their medical information from a doctor or the internet? Well, that would be these people. The combined percentage there, you can just go ahead and add them up because there's no sort of overlap in these. So that's 76%. So 0.76 of all of the responses, so of 1,200. And this is on a calculator section, so this is like your birthday question, man. This is one of the easiest questions I've seen on this test. Multiply for me. What'd you get? 912. Very good. So they're not all going to be nasty little questions, guys. Some of them are just going to be darn right beautiful like that. All right, number 7. The member of City Council wants to assess the opinion of all residents. Oh, I hate these questions. Okay, take a deep breath. Of all residents about converting an open field into a dog park. Okay, I already know what the issue is going to be on this one. Keep reading. I'm sure you'll find it fast. The council surveyed a sample of 500 city residents who own dogs. You see the problem already? Okay. The survey showed that a majority of these people were in favor of a dog park. Yeah. Quelle surprise. Why are they in favor of a dog park? Because they own dogs. It's biased. Nice vocab word. All right, which of the following is true about this survey? So right away, James went, biased. It is biased, so let's find it. Did you find it? D. They even used your word, James. Nice job. I like when they pull out the vocab because that really helps those of us who know what we're talking about find the right answer really quick. Sometimes they word it oddly. Like they'll mean bias, but they'll say something like, not representative of the sample, and therefore will skew the results. Like, okay, you could have just said biased, and we all would have been fine. Like, just say biased. So on that one, they did us a favor and actually used the right vocab. Thank you. Oh gosh, we got to the last page. Oh man, we're on a roll. Number 21. A study was done of the weights of different types of fish in a pond. The random sample of fish were caught and marked in order to ensure that none weighed more than, that none were weighed more than once. Sorry. The sample contained 150 largemouth bass, which is 30%, of which 30% were weighed. Weighed more than 2 pounds. Wow. Okay. I could read. Here we go. Which of the following conclusions is best supported by the sample data? Okay, so they sampled some bass, 150 of them, but only 30% weighed more than 2 pounds. So, is it true that a majority of all fish in the pond weigh less than 2 pounds? The average weight of all fish is approximately 2 pounds. Approximately 30% of all fish in the pond weigh more than 2 pounds, or approximately 30% of all largemouth bass in the pond weigh more than 2 pounds. Who did they sample? Largemouth bass. So the only conclusion you can make is about largemouth bass. So all of a sudden that became a very easy question. It's got to be D. So that was, I think we're kind of pulling out like, oh, the little trickery that they're pulling on you. They like to mess with the sample and then applying things to not the sample. So they're trying to catch you on that a lot. So if you don't understand whoever you're sampling, those are the only conclusions you can make is based on their original population, even if it's fish. You got to be careful about the wording. Oh boy. Oh, it's a voting question. I'm not excited about this. Okay, so in 2008, there were 21 states with 10 or more electoral votes, as shown in the table above, because we love tables. Based on the table, what was the median number of electoral votes for the 21 states? We just did a question like this yesterday. Do you remember what the issue was? We have a frequency table here, guys. So it's not as simple as like crossing off, crossing off, crossing off. So now that you guys know how to do this, if you wanted to, you could put this into list 1 and this into list 2, and then make sure this is the frequency list. And you are more than welcome to find the median that way. That will work, but I have a faster way if you're interested. Very interested indeed. There you go. How many states are in this business here? Like how many things are sitting here? You don't have to add them up because they're somewhere in your problem. It's 21, okay? What is the middle number? Like if you have the first number and then you have the 21st number, who's middle? And if you just tell me an ish number, I'm okay with that because it's a little complicated when you do this, right? It's like 11-ish? Yeah, it might be 11 exactly. So the 11th one is going to be your middle. So 4, this is 8, this is 9, this is 10, this is, I hope I was right with the 11. Yeah, I think we are. Whenever I get confused about that one, I just come up with an easier one. I go like, okay, 1, 2, 3, how would I find the middle number? And the answer is you'd add these up and then divide by 2. Okay, so you add up the ends and divide by 2 to find the middle number. I always screw that one up to this day, and I'm old. Okay. So the 11th one is the middle one, 4, 8, 9, 10. The 11th one would fall somewhere in this group, which means the median is 15, okay? Now, if it made you feel really happy to type stuff into list 1 and list 2 and find the median that way, you go for it, kids. You're excellent typers. You text message all day long. So I have no problem with you doing that. All right, number 6, and we are still in the calculator section, which most of this is, but now we're gridded response. So the chance of us guessing is very, very minimal. Now read carefully because there's probably something weird going on here. Andrew and Maria, they collected 6 rocks. Wow, guys. All right, the mean of the masses of rocks Maria collected is 0.1 kilograms greater than the mean of Andrew. This is just like, do you remember that question about the basketball points? This is that same idea, okay? So Maria, whenever we figure hers out, we know it's going to be 0.1 greater than the mean of Andrew's. So can you just hurry up and find the mean of Andrew? Did you already get it? I'm sorry. Huh? Did you find it? Oh, am I doing this a stupid way? Because that's always a possibility. Okay. I think it's 2.8. Okay. So if Maria is 0.1 greater than that, Maria's mean must be 2.9. So here's what you need to do. Maria's rocks, when she adds them all up and then divides by 6, it's got to come out to 2.9. So what's 2.9 times 6? So then tell me how far away from 17.4 she is when you take this stuff and add it together. Your teacher's getting awfully lazy in her math, isn't she? I'm just watching y'all work. You better get it right because it's graded response. 2.6 is good. Now SAT did mention that they will accept an answer of 13/5. Because that's an appropriate measurement for a rock. Like, why would you answer it like that? How dumb. Alright, anyways. No offense if you were thinking of answering it that way. Oh, look, fish. More fish. Okay, this is from SAT number 1. It's still the calc section. Oh, the bell's about to ring. Never mind. You'll have to wait till tomorrow, kids. The suspense is killing you, I know.